What's up everybody, CPO here, and I'm going to work on a little side project, and this is going to come in, I hope, really handy in the future as I continue to work on helis. But I'm going to build a leveling table. Not a level table, but a leveling table. So the point being that I don't necessarily want the tabletop or the countertop or the surface to necessarily be level, although that's helpful as well, I'm sure in some regards. But I would like to be able to use it to level a heli, particularly level the main shaft of a heli exactly perfectly. So with that said, I'm going to build a leveling table. So, and I've already got an idea of how I'm going to use this. You just have to wait and see what I have in store. But I'm pretty excited about it. And here in a couple weeks, I will have some awesome video for you with the use of this device. But in the meantime, I just want to build one. So I'm going to do this in a three-phased approach. The first phase is going to be fairly simple. It's going to be basic construction. Second phase is going to take it up a notch, and then third phase is going to be, as everything I do, a little bit over-engineered. So basically my first phase, all I really have here is a 2 foot by 2 foot piece of MDF particle board, and I've got some of these leveling guides. I got this stuff at Lowe's hardware store, and these are soft touch leveling guides, and they're designed, for furniture or what have you, to be able to adjust levels. I'm going to use 3 of these, and I'm going to use this board. And the reason I picked MDF board is because it's relatively flat. There's no warping or anything with this because it's pressed in the shape that it's in. So the chances of having a flat surface were, in my opinion, greater with something like this than trying to pick a piece of hardwood or pine or something like that that was completely flat. Cheap. I think I paid $4 maybe for this 2 by 2 piece of particle board. And then these leveling guides were like, I don't know, $2.50. So I've got $7 wrapped up into this for my phase 1 approach. Then, like I said, I'll take it up a notch, and then I'll take it up a third notch. And I've got some ideas in mind. But for now, I just like to build a platform that I can level if I choose to. So the first thing I want to do is figure out what size platform I need. I'm looking at I've got my 500 here, and I want to build this a little bit future-proof, so I don't want to build it to the size helis that I have. I want to think about bigger helis, right? This is a 500. There's a 600, 650 size heli in my future. I'm pretty certain about that. There may be a 700, which I'm fairly fortunate the 600 and 700 skid sizes seem to be about the same. It's my opinion, though, that this size, actually bracketed out with a square, is probably big enough to handle pretty much any heli I would want to set on here. So what I want to do is just build a platform that's this big. I could use the whole piece of particle board, or I could just cut it in half and make a 1 by 2, but I also don't want to make it so unwieldy that it won't fit on a work surface or anything like that. So I'd like to have it fairly compact and usable. So what I think I'm going to do is go with this 12 by 18 inch cutout here. So the way I'm going to do it is just basically make one cut here to build my width, or the length of 18 inches, and then I will just cut the board in half to get it at 12. So that'll essentially give me 2 pieces of wood of the same size. So let me go ahead and just get my 18 inches marked out. So 18 minus 24 is going to be 6, right? So I can come down here and use my square and set a 6-inch mark. And another 6-inch mark. And then I'll just align these. Using this square for what it was invented for. All right, so there is my my first cut line. That's going to make this 18 inches. Let me just double check that measurement. Yep, gives me about 18 inches. Now what I want to do is build a 12-inch mark. And make my mark. All right, so that should give me two 12-inch pieces of wood. And so that's my cut line. And I'm going to take care of getting that cut up. And then we will move to the next step. So before I go cut, I do want to talk a little bit about the leveling feet. And in particular, the number of feet I plan on using. These came in a 4-pack. But I'm only going to use 3 of them. And I'll explain why. And basically, you would think, and a lot of people would think, maybe put your 4 feet on the 4 corners of the platform, and that'll make it stable. And of course, with each corner being adjustable, you can level it, and that's exactly true. That is possible. However, it's been proven that trying to level 4 points onto one plane is a little bit of a challenge. It always seems that there's one of those points that is a little bit tricky to get resolved. So we've seen this with RV leveling and automobile leveling and other sort of leveling instruments. Printer beds for 3D prototype printing. They've all gone through this 4 versus 3. The problem with 4 is it takes 3 points to define a plane. So if I take one out, right, and I have a triangular shape, it will always sit flat on a plane. So if you think about a bar stool, for example, with 3 legs, never does have a chance to wobble as long as all 3 feet are touching the ground. Even if one foot is shorter than the other, or think of a tripod, a camera tripod, even if one foot is shorter than the other, it's still going to be solid on the ground. Take a chair, for example, and if one foot is just a little bit longer or just a little bit shorter than any of the others, then you've got this wobble thing happening. So you know how annoying it is to sit at a restaurant table and there's just that little bit of a wobble. That's the challenge with 4 points. It takes 3 points to make a plane. The 4th point then has to match perfectly the plane, which is the hard part. So it becomes a simpler design to use 3 points instead of 4. Now 4 gives you better support because you've got support in all the corners. But with that said, I mean, we're not talking about a lot of support needs here, and I could essentially, build a triangle platform that would work fairly well. So that's what I'm going to go with. I'll keep this as. I guess I'll just throw that one on the floor. At any rate, that's why I'm doing 3 points instead of 4 points. I'll resolve exactly where I'm going to mount these. I've been debating what positioning to use on this. Time will tell here how I actually work that out. But I am putting some thought into that as well. I'm not just haphazardly putting it together. So anyway, that's a 3-point versus 4-point discussion. Let's go cut this wood. All right, one last thing before I go cut, I promise. And that is just real quick, if you're not familiar with cutting this particle board, what I generally do is take masking tape, and tape over all of my cut lines. And I tape all the way around, front and back. And basically what that does is it prevents chipping and splintering of the wood. I'm going to use a circular saw to cut this. So if this is new to you, I mean, just a little bit of tip is to tape this down, make your cuts, and then remove the tape when you're done. So it tends to work well for me. So hopefully that'll help you. Oh, one more thing before I cut. I'm just messing with you. This is cut. So basically, I have cut the segments that I said I was going to cut earlier. It gives me 2 identical platforms, and then this extra piece that I can use for other things. Again, there's nothing wrong with making a leveling platform with this entire 2x2 piece of wood, or whatever size wood you have. I just wanted something that could fit on my workbench fairly easily without having to remove a lot of stuff, but yet would be big enough to easily hold a heli of any size, or anything else. There may be some other needs that I'm not even aware of yet that I'm going to put this to use with. But anyway, this is my my level piece of board. Again, if you've got regular board, this thing could essentially be 0 cost, or at most $2.50 for a pack of these things. So if you've got wood laying around, use it, because you're going to level anyway. And again, my concern isn't so much having a level work surface as it is being able to have an unlevel work surface that in turn levels a heli. So, and I'll show you more about that later as we get going. But for now, I want to figure out where to place these. I think what I've pretty much resolved is that I'm interested in, obviously this one is, I'm doing the triangle approach here. So I'm going to have this one near the back, and then I'm going to have these 2 near the front, assuming that I would put it like this. It makes more sense to me to have the center near the rear center of the heli, because it's going to align nicely with the normal heli adjustments. If you look at the servos, you've got 1 right, 1 left, and 1 rear. And so if I'm trying to level things, it makes sense to level in the same fashion. So that's how I'm going to do that. Basically what I'm going to do is use my, my square here to make a mark an 1.5 inches. That way I'm getting basically a nice straight line. My line doesn't have to go all the way through. I just need to make sure I hit the center point. So basically, this mark right here is where I'm going to drill to put that foot. And that foot should be centered left and right, and then 1 1/2 inch in. And that's an arbitrary figure. I just came up with 1 1/2 inch just because it seemed like a good distance. Not too close, not too far away. Again, I don't want to get in the way of the heli, so I don't want to have it all the way in here. And for stability, I think as close to the edges as you can get is pretty good without having it too close to where it's kind of a pain. So anyway, I just made that number up. You can do it closer to the edge or further than you if you want. So from here, I'm going to do the same thing with my corners. I'm going to do 1 1/2 inch in. And so let's just make those measurements really quick. Because I have a square, I can measure the 1 1/2 on this plane and the 1 1/2 on this plane, and draw my dot right here in the middle. That's the value of having a square. Use the tool for what it's designed for. Most of the time, I don't use the tool for what it's designed for, and I do things the hard way. I think we're all probably like that to some degree or another. Alright, my final design is going to look like that. Now it doesn't matter what the top or what the bottom is right now, because I'm going to drill these holes all the way through, and once I put my feet on, then the feet will obviously point down. And I'll show you a little bit about why I chose these leveling feet as well here once I get going. But right now, I want to drill holes for these feet. I look at the instructions, and it says to drill a centered 3/16 starter hole. Makes sense, starter hole. And then determine if your furniture leg is made of softwood or hardwood. I'm going to assume we're going to go with a hardwood value. For hardwood, drill a 3/8 inch diameter hole. So basically what I'm looking for is a little pilot hole to start it, and then I'm going to do a 3/8 inch hole. And the 3/8 inch hole is going to allow me to press in this little plastic receiver that the feet are going to screw into. So that's it. I'm going to go drill 3 holes, 3/8 inch in diameter. All right, there we go. I've got my holes drilled in the corners, and then the one here in the middle and the back. And you can decide which end you want to be up or down at this point. And as a matter of fact, if you're really crafty and you decide you want to paint this thing, now's the time to paint it. I mean, you've got your holes drilled. Before you put it together, you know, throw some paint on that bad boy if you want. Heck, let's do it. All right, so here's my board. I decided to lay a little bit of white paint on it, and I only painted the one side. I didn't paint the bottom side, and I didn't spend a whole lot of time on the edges. Just wanted to throw a little bit of a surface on it, and there's kind of a reason for my madness. One of them is I just had some paint laying around. I had some white primer and white gloss paint from a Pinewood Derby project my son and I did a couple years ago together. So I just had that laying in the garage. If I didn't have any paint laying around, I don't think I'd go buy paint necessarily for this. But I thought I'd put a nice finish on it. And the reason I think white is a better color than anything else is most of the parts that we're working with on our Helis tend to be either black or silver. So I wanted something that would stand out. If I dropped a part on the board, I wanted to be able to see it fairly readily. So I think that's the benefit of having white, in my mind anyway, as a work surface, as opposed to the unfinished wood or any other strange color. But your mileage may vary. Anyway, I just had this laying around. If I didn't have it, like I said, I'd probably just go with that unfinished wood, which isn't too bad for parts recognition. But anyway, so now we have our paint. You know, in hindsight, I might have painted the other side instead of this side, just because this is the bottom when I drilled, and the holes are a little bit rough on the bottom side, as they usually are. They're a little bit tighter on the top from the drilling perspective. It doesn't really matter. The other thing is, I had a little bit of a bug mishap. I painted the thing and, you know, probably had it sitting for a minute before a bug goes and lands on it, sticks to it. So I had to do a little bit of a touch up there to remove the bug guts. Anyway, so again, I'm going to mount these bad boys. And in order to do that, I want to flip this over to what's essentially going to be the bottom of the unit, okay? And then just unscrew these little plastic caps from your feet. And basically what we're going to do is just press them in there face down. Then that will give us a place to screw in our feet. I am going to put down a softer surface here on this table. This is still just a little bit wet, just tacky. But I can't wait any longer. Let's just get this done. All right. So from here, basically what I want to do, a couple really light hammer blows, and those are going to go in just fine. Just get them pressed in there, and you're good to go. Once you have that, you can screw your feet in. I'm going to screw these all the way down until they're snug. And it's actually going to lift the table up off the surface because, as you can see, the screws are longer than the wood is wide, and that's by design. I actually did that, had that in mind whenever I made this, because I wanted to be able to adjust from the top. So with these screws sticking through, I can turn this, counterclockwise to raise. Let's see, clockwise to raise the surface, or counterclockwise to lower the surface. Now I also have something else in mind, which is to put a nut on the top here, some sort of a cap that I can use to turn. I haven't got that far yet, but anyway, that's the basic design of my leveling surface. It's a 3-point leveling surface. Alright, so I have a level sitting on there, and it's a good old-fashioned bubble level, which doesn't lie. And you can see I'm already almost level, just how I have it set by default. If I turn this clockwise, you can see how it raises the, on your screen, it's going to raise the left part of the table. If I turn it counterclockwise, it lowers it, and you can fairly precisely level this from left to right. Now if we turn it and we look at the other axis, you can see I need to make some adjustments to the front. So there we go. Let me give you a straight over the top view. So you can see that's level that way. And that's level that way. What about diagonally? Good to go. So this is a completely level surface using 3 leveling feet. Now, what can you do with this? All kinds of cool things. Not quite done building it yet, though. So before I talk about that, let me go find some caps to put on these to make turning these a little bit easier. I think that will be the finishing touches for me. So this is what I'm going to use to finish the tops of these. It gives me a good surface to rotate them clockwise and counterclockwise. Gives a nice finished look to it, but more importantly, just gives me something to grip onto. Now the challenge with these is they're fairly deep. This is just an acorn nut, by the way. Picked it up at the local hardware store. They're fairly deep, so if I thread these on all the way, I'm going to lose a lot of my adjustment room. So I started looking around to see what I had to solve that. And basically I have a whole ton of these little guys laying around, which is these little brass inserts for the rubber dampeners for the servo mounts. So what I thought I might do is just take one of them, set it on top of that screw there, and then when I screw this down, it just screws down a couple threads before it gets tight. It locks in basically. It bottoms out on that. I can thread lock that in place, and then now, as you can see, I've still got plenty of room for adjustment up and down. Literally, probably a ½ an inch or more of adjustment room for that foot. So that's the method I'm going to use. And like I said, this is just going to act as a spacer. And you could use anything as a spacer that will fit in there. I just happen to have some of those laying around that I'm not using. So I'm going to put some thread lock onto these threads. I'm going to snug it down. I'm just going to hold that bottom foot and then finger tighten it. That's really all I need to do. The thread lock is going to do the rest here after a bit. But now you can see how my adjustment works. and I can just turn that up and down to raise and lower that table. So I'm going to do that same thing to those other 2 feet, and then we'll take a look and see where we're at. Alright, so here it is. This is phase 1 leveling table. This is as basic as it gets, okay, with a little bit of extra paint, but the reality of it is this is a very simple device. 3 leveling feet, which is going to allow for simplified adjustment to level your plane in any direction that you need, as well as provide a fairly adequate work surface. Again, you just need to turn these little knobs to adjust your level, whether it be side to side or forwards and backwards. So you could, you know, this is it for just a few bucks. I think I have $7 or $8 in this thing. If I already had wood, it could be down to $3 or $4 tops. Now, the one challenge that you may want to deal with is the fact that these little feet, on the one that I got anyway, these feet that I got are a little bit slippery, right? So you may want to lock this in and not want it to slip and slide around. So you could put whatever you want on this. You could get like a felt surface to stick on there. You know, you got those felt pads they use for hardwood floors and stuff. You could use a rubberized surface. You could do a myriad of things to make this a non-skid surface, because what you don't want to do is get it all set and adjusted where you want it and then have the thing sliding around on you. So I'll look around and see what I've got, but for now, this is just the basic phase 1 3-point leveling surface. So get back to the level here. I think the ideal solution is to level it left and right first. Get that adjusted that way, and then level front and back. And there we go. A perfectly level surface. Now, I told you I didn't get this to level the surface, more so to level the heli. But you could use a perfectly level surface to zero or check calibration on a pitch gauge, for example. I know that now this is a flat surface, so if I was wanting to calibrate a gauge, and some digital pitch gauges do have a calibration feature, it's nice to have a known level surface to make that calibration off of. Just for fun, let's see how much variance we have for getting our level here. I'm going to put this in the completely down position, and I just want to see, get this pitch gauge zeroed out right there and change your view so you can see it as well. Alright, so just turning the one screw that's going to change the elevation forwards and backwards. Let's just see how much room I have for adjustment. So it looks like I can adjust it 0.8, 0.9, so almost an entire degree of adjustment. So I'm limited by these little acorn nuts that I put on top, so without them I could adjust even further. And of course I'm also limited by the height of these bolts that are coming out of the top of this. So there may be some of these leveling feet that have longer bolts, which would allow for more. But I would say I can't think of a reason why I would need more than a 0.8, 0.9, almost an entire degree of adjustment. So what this means is if you're out in the field and you need a flat surface for whatever reason, I'm not going to try and guess why you need a flat surface, but if you're out in the field and you're on a picnic table somewhere and you need a perfectly level surface, this could help you achieve that. So inexpensive and simple. So phase 1, right? So phase 2 Oh, first, let's talk about getting the heli on there. So I have a heli. Here's one I'm building. This is a 500 I'm working on. You can see, number one, there's a problem with getting the heli to lay flat, right? Always a challenge. If I had a battery tray, I could put a battery on there to hold it down. But also, you want some stability while you're working on your heli. So, initially for this particular level of build, you can just tape these down. Take some masking tape or something like that, and just tape the skids down, and that should hold it in place for you. But phase 2 of this build, I'm going to step it up a notch, and I'm going to add a helicopter strapping mechanism. And I want to make sure it's something that I can use no matter what size heli that I'm working on. So if it's not the 500, if I've got the 450 on here, how would I strap it down using the same mechanism? If I had a 700 sitting on here, how would I strap it down using the exact same mechanism? I didn't want to have to worry about different ways, different skid types, right? So this isn't a standard tube skid, it's a carbon fiber skid. So how do I make sure that anything can be strapped down easily? So that's what I'm going to talk about in phase 2 of this. But again, if you just wanted a simple leveling table, this is it. We're done. So, but let's strap the heli down. So there you go. Here's my phase 2 addition. A couple little eye bolts and a couple of springs. Now, picking out springs was a kind of a challenge because I wanted something that was good and springy, that could handle a short amount of distance or a long amount of distance, depending on the size of heli I was working with. And it had to have these little hooks so that I could easily hook them on and not have to use any tools to take the heli on and off. So I got one of these springs. It's got the big hook on either end, and I'll show you how I plan on using this. So the first thing I want to do is get basically the smaller heli on there and use that as a starting point for my measurements. So what I plan on doing is I plan on using these as hold down springs, where I'll have an eye bolt stuck into the surface, and then I'll just use a spring and just clip it onto the heli anywhere. You can clip it anywhere on the carbon fiber just to kind of hold it down. So it doesn't matter what size heli, because this spring can stretch farther or shorter depending on my needs. But what I want to do is make sure that the placement of the eye bolts is in a place that doesn't get in the way of the heli. So what I think I found out is if I center this heli, and this is not the center point yet, and I establish the spring points just on the outside of the skids, okay, and I take that heli off and I put this heli on, now my spring points are just inside the skids, right? So as far as strapping the heli down, it's not going to make a difference. And then if I go even bigger, a bigger size heli, it'll still be inside the skid. So basically my point is if I use that as my reference, then it shouldn't matter if I'm using this 450 or something smaller, or if I'm using the 500, 550, 600, 700, something bigger, these eye bolts will be just out of the way. So with that said, what I want to do is measure that distance, and that'll get me pretty close to where I want to be, and I'll probably add a little bit of length or width to it. So whatever that distance is, I'll add half an inch or so to give me some extra room. And then I just want to center that on the plane. And then what I'll probably do is center it. Well, I'll have to figure out then where I want them on this plane. So let me measure that and put my eye bolts in, and we'll go from there. All right, I decided to go with 5 inches as a measurement. That's, as you can see, just on the outside of where I left those springs. If I compare it against the 450, it's well outside the skid range of the 450. And if I compare it to the 500, it is within the skid range of the 500. So I think 5 inches is a pretty good spot to be for that. Now what I need to do is just basically find my center point, and it's going to be 2.5 inches off center. Now, as far as where I want the spring eye bolt positioning to the left and right, as you're seeing it on the screen here, I'm going to go with the center point again. So from the center point, I'm going to go 2.5 inches this way, and then dead center from the left to right angle, and that's going to basically have me centered between this plane where these leveling feet are. And essentially, as far as stability goes, you want to do all your work inside. There's basically an imaginary circle that is at the edges of these leveling feet. As long as you're working, primarily within the triangle, but as long as you're fairly well within that circle, it's a fairly stable work surface. If you get out here and you're doing stuff, as you can see, it's not as stable. That's one of the downsides of a 3-point. As long as I'm doing most of the work on the Heli in here, it's actually a really stable work surface. Anyway, back to the springs. Okay, there we go. I've got my my eye bolts through, and some advice here. You've heard the old saying, measure twice, cut once. That's very sound advice. You can see I almost started right here to insert an eye bolt, and then decided to double check my measurement, and I realized I was an inch too far towards the middle. I was thinking 1.5 inches on either side of center, and not 2.5 inches. So double check your measurements before you start doing things. It will definitely save you some time in the long run. So now I've got these eye bolts in there, and let's test and see how my theory works. So what I want to do is get a spring, and basically what I'm doing is aligning it so that I can easily clip it onto the Heli. And then let's take a 450, set it on here, even if it's not even centered, but let's just clamp it down on both sides, and there we go. We have a fairly stable work surface with a fairly stable helicopter. I mean, it's obviously, you can pull it off of the surface, but it's going to stay pressed down while you're working on it. Particularly if you're doing things where you're concerned about level, you're probably not going to be moving it around and shaking it too much anyway. It just keeps it from rocking. It allows me to have it pressed flat against the surface without a battery. Let's see how it works with the 500. Because really that's going to be what I'm working on next. Now again, the 500, the skids are going to go on the outside, right? So find some place to lock this thing down. Now the 500, what I'm finding is, needs a little bit more spring tension, okay? So I may want to consider that. When you buy springs, you may want a heavier duty spring for the 500. If I clip it up here just at the top of the frame where the main gear is, it does hold it down pretty snug here, and I've got still plenty of room to do the adjustments that I need to do. So all I'm looking for is something to hold this thing down so it's not rocking and moving around while I'm working on it. So that's pretty much it. All right, so let's say I wanted to level this this top block here. Let's find out how I would do that. So the key to the 3-point leveling system, and I'm going to get this all out of adjustment, just intentionally totally messed up. So I don't know what the level is on that. Basically I'm moving them all around. So the key to a 3-point system is you want to level using these two first on this plane, right? Then you want to adjust your elevation fore and aft. The reason this is centered is that when you lift this up, it should lift up evenly on whatever plane these are set at. So let's just, I'm going to use an old school mechanical level. So basically what I want to do is get my adjustment so that this is level left and right. I want to move it really close here. Okay, so That is level that way. So I'm level left and right. Now I want to level front to back. So make sure you're getting a good spot. I mean, there's a lot of places on the Heli. This you know, has a little bit of wiggle room. So I just want to make sure I'm fairly certain it's flat. And then I'm just turning clockwise until I get it leveled. And now I should still be level side to side. All right. So in theory, and hopefully in practice, this head block is perfectly level, which means my main shaft should be level as well inside of there. Which means if I wanted to do any measurements off of the main shaft, then it should be level. So let's unscrew this top button on the main shaft. So let's just see how we're doing on a level of our main shaft. That's pretty darn good given the fact that all I did was level the bearing block. But now let's finite level this with the fine-tune these adjustments, making sure, again, you got to make sure that you got there's a lot of room for this thing to get out of whack if you're not careful. Using a spirit way is the way to get it level to the earth, but is a little bit more challenging in this particular application. Okay, so make some adjustments. Alright, so I am level now regardless of the direction that this main shaft spins. My main shaft, my head block, is perfectly level. Which means things that I do to set up the head that require level can be done off of the main shaft, because the main shaft is now level. So anyway, we're going to get into more about this. This is for those of you that are meticulous builders. A lot of people aren't going to care about this, to be quite honest with you. But again, I have something coming up in the next couple of weeks that I'm going to take advantage of this. And I'm pretty excited about it, and so I wanted to build it just for that reason. So that's my basic phase 2, right? Phase 2 is finding a way to strap the Heli down. Again, this bigger Heli may require a little bit more spring tension. So, you know, I may end up getting a couple different size springs. You know, a heavier spring is going to hold it down a lot tighter to the table than a lighter spring will. So I may consider that, but right now even this 500 is held in there fairly well. If I put a battery on the front, it would definitely not go anywhere. But it's doing what I need it to do, which is sit flat on the table and then essentially be level. Let me try one more time. Let me put this thing back in there. Let me check this lock. Show enough. We're still good and level. So anyway, I dig it. So if you're interested in this, have fun. If you have any questions, let me know. Any comments, feedback, always appreciated. Phase 3. Remember, Phase 3 is over engineering and over the top, as per the typical CPO way. And some of you may argue that this is already over engineered for something so simple. But Phase 3 is going to involve, hopefully, the ability to rotate the surface while still keeping it perfectly level. That's going to be the challenge, is getting it rotated and still level. I've looked at several options, including like Lazy Susan bearing assemblies, but they're not reliable in the fact that as you turn them, sometimes they come out of level. So I have a low-budget, low-tech idea that I'm going to apply, and that'll be coming up in video 2. So for now, this is CPO's 3-point Heli leveling table. So thanks for watching. Hope you enjoyed the video, and I'll catch you on the next one.